Hi, in this video we continue with the study of how to design some surfaces from curves. We will focus our attention on the case of doubly ruled surfaces. The main goal is to model structurally interesting surfaces constructed from curves. The structurally interesting surfaces we refer to are those that can be constructed from two families of straight lines. This is the case of the hyperboloid of one sheet used to construct the cooling towers of power plants, and, for example, the case of the hyperbolic paraboloid used in some decks, as for example the deck of the church Nuestra Señora de la Soledad in Mexico, designed by Felix Candela. A ruled surface can be described as the set of points swept by a moving straight line. In particular, we are going to consider the doubly ruled surfaces. We start with the circular hyperboloid of one sheet. It is the surface obtained by rotating the straight line around the axis of rotation. Note that the line must not be parallel to the axis, otherwise we would get a cylinder. The parametrization of that surface is obtained by rotating a straight line around the axis. We can think of a moving line around a circle, and we consider the circle to be that one of radius 1 on the plane z equals 0, whose parametrization can be seen on the screen. We consider for direction of the vector of the line the vector obtained as the sum of the tangent vector of the circle at each point and a vector orthogonal to the plane z equals 0. Note that with the parameter h we can control the slope of the straight line. We have then the parametrization of the surface. And note that if we fix the value t, then the parameter s parametrizes a straight line. We can easily repeat the construction by considering the director vector of the straight line as minus the tangent vector of the curve plus the orthogonal vector to the plane z equals 0. In this way, we get another parametrization of the hyperboloid of one sheet. And through any point of this surface, there are two lines. In this way, we get a hyperboloid of one sheet as a doubled ruled surface. And this construction is structurally interesting, as we can make a good formwork from it. Between two layers of these surfaces, we can put concrete and make a good construction of it. And the Tower of the Parliament at Chandigarh is a nice example of a hyperboloid of one sheet. It was designed by the architect Yanis Xenakis. Another nice example can be found in the Basilica of Our Lady of Coromoto, Venezuela, designed by Felix Candela. We now consider the example of the hyperbolic paraboloid. It is the ruled surface formed by straight lines that rest on two non-coplanar segments. That is, we consider two segments, the one with endpoints P and Q, and the other with endpoints R and S. Now we consider segments with endpoints in these two red segments. Moving the endpoints along these two red segments, we obtain the hyperbolic paraboloid. We now parametrize this surface. We first parametrize the two red segments PQ and RS. The direction vector of the lines is the vector with endpoints in each of the segments. And we then obtain the parametrization of the surface by adding to a point in the segment PQ a vector in the direction u of t. Note that for each value of the parameter t, we obtain one blue segment. We can easily repeat the construction by considering the direction vector of the straight line as joining the points of the segment PR and QS. We obtain the corresponding direction vector and another parametrization of the surface. We have parametrized the surface in two different ways. such that for each parametrization we can see a family of lines forming the surface. Therefore, we have seen that the surface is a doubly ruled surface. And this surface is also useful to make formworks. You can see the formworks of the Philips Pavilion down for the Universal Exhibition at 1985 at Brussels, designed by Le Corbusier and Xenakis. We finished this video with another construction of the architect Felix Candela. He used in many different ways the two surfaces presented in this video. Actually, we refer the student to the video of Vimeo indicated on the screen for a very nice review of Candela's work.